Okay, so what we're looking at here is an example from 2016, Solids Revolution number 5. Now, this is supposed to be done without a calculator. This problem is one of the more difficult ones that I've seen, and you'll see for a variety of reasons. But you're not supposed to be able to have a calculator, so let's just jump right in and take a look at what we've got going on here, okay? It says the inside of a funnel of a height 10 inches has circular cross-sections as shown in the figure above. At height h, the radius is given by, then we have this function right here. The units of r and h are inches. Now, this would have been a lot easier if they told you that this is what the function looks like, but instead they give you like the end result of revolving it around the x-axis. And again, this is just r equals the 1/20th multiplied by 3 plus h squared. So if you understand that, it's not quite as bad, but it's still kind of a rough question. Okay, so it says find the average value of the radius. Well, in order to find the average value of the radius, we have to do the integral from a to b, so that's from 0 to 10, of that particular function. So I've got 3 plus h squared. And then I'm going to divide by how long it took, and that gives me my average. And I've got dh on the end. Well, and again, with a calculator, this is really easy. But without a calculator, unfortunately, we're going to have to do a little bit more work. So I'm going to move the 1/20th out in front. That's going to be 1 over 200. Then I'm going to take the antiderivative of 3 plus h squared. So that's 3h plus h to the third over 3. And then we put in 10 and 0. So I get 3 times 10 plus 10 to the third, or excuse me, 10 to the third, not 100, but 10 to the third divided by 3. Then we multiply that by 1 over 200. Oh, I also have to plug in 0. So I get 3 times 0 plus 0 to the third divided by 3. When I multiply that in and I do all the work, it does simplify down to 109 over 60. Technically, this answer is good enough for this problem, and you can just leave your answer like that. But again, a little bit trickier because we have to do that one by hand. Letter B wants us to find the volume of the funnel. In other words, it wants us to take this and revolve it around the x-axis. So I'm going to have pi times the integral from 0 to 10 of 1/20th times 3 plus h squared. Now again, with our calculator, that'd be pretty easy to plug in. But without, I have to square both of these. 1/20th squared is 1 over 400. So I'm going to move that 1 over 400 out front. And then I've got the integral from 0 to 10 of 3 plus h squared. Now 3 plus h squared is 3 plus h times 3. Well, I guess we could work with it this way. I've got 3 plus h squared. I don't need to multiply that out, because when I take the antiderivative of that, I get 3 plus h to the third divided by 3. Then I'm going to plug in 0 and 10 again. So I'm going to get 3 plus 10 to the third over 3 plus, or excuse me, minus 3 plus 0 to the third over 3. That's what I get for that part right there. Yeah, that's right. And then I'm going to multiply that by the pi over 400 out front. If you simplify that down, you get 2209 pi divided by 40. Now again, that one's tricky, but that's what we get when we do that. Letter C is actually a related rates problem. So what we're going to do is we're going to take the derivative of this with respect to time, then we're going to plug in some of the stuff, because I haven't used this height of 10 inches so far. Okay, so I take this and I go r dr dt, excuse me, we're taking the derivative with respect to time, is equal to the 1/20th times 2h, because that's the derivative of 3 plus h, and I can ignore the 1/20th because it's a constant. Then I'm going to put dh dt. Well, I know at the time in question, at the instant when the height of the liquid is h equals 3, so I'm going to put 2 times 3 right there. I've got 1/20th. It says the radius is decreasing at a rate of 1/5 inch per second. So that means dr dt is negative 1/5. We still have dh dt, which is what we're looking for. So I have to divide both sides by all of this stuff. Okay? Now again, on the test, you can leave your answer just like this. It doesn't look good at all, but I can leave my answer just like that, and that is correct for dh dt. It does simplify down quite a bit. You actually get negative 2/3 if you simplify that down correctly. But that is the correct answer for letter C. Now again, there's an awful lot going on in this problem. Not one of my more favorite problems. There's tons of algebra that you need to do in order to solve these, as well as those antiderivatives were kind of tough as well. But if you have any questions about this problem or any other problems, please let me know.